In this video, I just want to introduce to you what the sine law ambiguous case means. Now let's say that I give you a triangle and I say that angle A is 30 degrees, side A is 10 centimeters, and side C is 16 centimeters. And let's figure out what angle C is. Now I already have the full solution here. What I've done a little bit differently is this step right here. Now normally I wouldn't ask you to figure that out, but inside our brackets here, inside our sine inverse, it actually ends up giving us 4 over 5 or 0.8. So the sine ratio is 4 over 5, and that gives us a 53-degree angle for C. Now we have to think though, all angles in a triangle have to be less than 180. So it is actually possible to have an angle inside of a triangle, maybe not the way that I drew it, but an angle in a triangle could be like 150 degrees. Now, if the sine ratio is positive, we know from our last unit that this angle or this ratio doesn't have to be in quadrant 1 only. The sine ratio is also positive in quadrant 2. Okay, so if we consider this drawing that I have right here, so let's say that this first measurement that we have is 53 degrees. Because the sine ratio is positive, I know that it could also happen in quadrant number 2. Now, the related angle would be the same of 53 degrees, but if you rotate all the way around, what the actual angle is, if you rotate all the way 90 and then plus this amount right here, or the other way to think about it is 180 but then take away 53 degrees, that angle C could also be approximately 127 degrees, which could be an angle inside of a triangle since it's less than 180. So this actually gives us, for the measurements that were given of 30 degrees and 10 centimeters, so that pair right there, and also 16 centimeters, it's actually possible to draw another triangle using those same measurements. So I have that over here. So this is the original triangle that I had, and we just found that angle C was 53 degrees. But it's also possible, if the triangle was drawn in this way, angle C could be 127 degrees. So you can see that it's bigger than 90 degrees there. But all the measurements are still in the same place. So side C is still 16 centimeters. Side A is still 10 centimeters. Angle A is 30 degrees. But this is actually still a complete triangle with this 127 degree angle. So what we're going to look at in class when we talk more about this is that by giving just 3 measurements, so 2 sides and 1 angle, it may not necessarily be only one triangle that is possible. It might be possible to draw 2 triangles, or perhaps we might see if I give you certain measurements, it might not even make a triangle at all. So we'll be looking more at that in class.